is true. Okay. I want us to show this. Given 1 plus 5 plus 9 plus 4n minus 3 equals 2n or 2 minus n. I want us to show for what? Show for n equals 1. We assume for n equals k plus 1. No. N equals k. And 3. Prove for what? N equals k plus 1. Let's attempt this with the knowledge of what we have solved in the last two examples. Can someone help me to clean up these two? Let's attempt this. Let's attempt this. Let's attempt in 2 minutes.
No, as well.
I think are you? So basically, if you show that a base case is true, and you assume
But everything is based off of the base case is true.
if you assume the base case is true, and you can show that the next one is true,
Yeah.
then that means like starting out one, the next one, the next one.
Yeah, you can assume that.
So
the rest
you
of
can
it.
do that. I don't remember the first part. The second part is you plug in k to everything. That equals each other. And then plug in k plus 1. And you show that it equals the original equation.
Okay. Are we still solving? Oh, we are done. Nobody yet. Okay. 1 more minute. Okay. Are we done? We are not done. Okay, that's okay. Let's do that together. I don't know. For many times that I've taught this course, I don't know. This topic, I don't know why people always have this problem of in this topic, mathematical induction. So first of all, we start from the first one. We say let n equal to 1. Hence, 1 is equal to what? Two minus 1 will give you 1. The next one, let n equal to 2. Hence, you have 1 plus 5 equal to 2 power 2 minus 2. There you have 6, you have 6, right? Is that clear? For n equal to 3, 1 plus, for n equal to 3, first 3 terms equals, for the right hand side of the equation, you have substitute the value of 3 for n. 2, 3, power 2 minus 3. That is 15 over 15. 3 raised to the power 2. 9. 9 times 2, 18. 18 minus 3, 15. 9 plus 5 is 15. So, we'll go straight to prove that it is true for what? We assume that it is true for what? N equal to k. And you have 1 plus 5 plus 9 plus k minus 3 2 k squared minus k. Is that clear? Also assume that, also prove that it is true for n equal to k plus 1. Hence, you have 1 plus 5 plus 9 plus 4k minus 3 plus 4k plus 1 minus 3 equals 2k plus 1 over 2 minus k plus 1. Right? So from here, discover that everything from here to here is what we have here. Right? You substitute. Hence you have 2k over 2 minus k plus 4k plus 4 minus 3 equals 2 into k squared plus 2k plus 1 minus k minus 1 implies 2k squared plus 3k plus 1 equals 2k plus 4k plus 2 minus k minus 1. As you have 2k squared plus 3k plus 1 equals 2k squared plus 3k plus 1. Hence, what we have here is the same thing as what we have here. Who got the same thing?
I didn't finish.
Don't you what happened?
I would get there.
Yeah.
Eventually.
You got it, right? Good, ahead. Good. Good. So, hence, the mathematical statement is true. It's true. Should we try this? Let's try this also. Try this. What's the next distance? have 3 plus 7 plus 11 plus. Okay. Plus 3 It seems like we have solved something like this, right? We have solved this. Previously, yeah, we have solved this. We have solved this previously. Not the first example. Instead of us done with this. Good. How many persons? How many are we? How many of us are done with this? So what do you get? 17?
Yeah.
Balance equation. If you got it, thumbs up. Good. Let's solve this together first. We want to solve for the first one. Length n equal to 1. Hence, we have 3 equals, so put the value of 1 here. 1 multiplied by this will give you the 17 here. Right? So we have 1 here. Multiply by this will give you 2. Plus 4 will give you 3. That means 3 is equal to 3. This is equal to 3. We say this less the power. Less n equal to 2. Hence, we have 3 plus 7 equals 2. 2 times 2, 4. We have 4. We have this. Hence, here you have 10. Hence, here you have what? 5 times 2 give you 10. If we go further, so go for this. For n equals to 3. You see that 11 plus 3, 18 plus 3, 11 plus 7, 18 plus 3, 21 is equal to same side 21. So go ahead to prove for n equal to k, which you have 3 plus 7 plus 11 plus 4 k minus 1 equals k 2k plus 1. Then you prove for what? N equals k plus 1. Okay. From this, what do we do? Okay. 3 plus 7 plus 11 plus 4 k minus 1 plus 4 n plus 1. I mean k plus 1 minus 1. It was n and this n. K plus 1 into 2 k plus 1 plus 1. Hence, everything here to here is this. Hence, so to develop this as k into please, could someone please clean up this side? Everything that side. We have k two k plus 1 plus 4 k plus k minus 1. It was k plus 1 2 k plus 2 plus 1. Hence, we have 2 k squared plus k plus 4 k plus 4 minus 1. It was 2 k into 2 k plus 3 plus 1 into 2 k plus 3. And we have 2 k squared plus 5 k plus 3 equals 2 k squared plus 3 k plus 2 k plus 3. Hence, 2 k squared plus 5 k plus 3. Hence, you have 2 k squared plus 3 k plus 2 k, 5 k plus 3. Hence, what we have in the left hand side is same as what we have in the right hand side. Hence, the mathematical statement is true. So we go back to the next topic, which is what? Not math here. That's the very matrices. So matrices is simply an arrays of number in a row. Arrays of number in a row and in a column, enclosed in brackets. An arrays of number enclosed in a row or column. A, B, C, D. So this is row, this is column, and this is, you can call this 2 by 2 matrix, right? So the horizontal arrays of number is called the row. While the vertical arrays of number is called the column. The dimension of a matrix is m times n is where m is the row and m is the column. So we have 2 by 2 matrix. This is 2 by 2. We have 3 by by 3. That means you have 3 rows, 3 in a row and 3 in a column. Then addition and subtraction of matrices. The first thing you need to know is, for you to add and subtract a column, it has to have the same dimension, row and column dimension. In the sense that if you are given a matrix, this matrix A, given A equals to this, A, B, C, D. And your B is what? A, B, C, D, E, F, G, H, I, and you have to find A plus B of this matrix, or maybe A minus B of this matrix. This cannot work. It's not possible because for you to add or subtract a column, it has to need to have the same dimension of row and column. But this is not true. The same for multiplication. You know, most times multiplication can go anyway, just like we do in indices. You know, most times when you can multiply you can multiply 10 and I, maybe 10 times A. 10 times A is 10A. But if you want to add 10 plus A, 10 plus A is the same thing as 10 plus A. You cannot bring them together. So, this addition, subtraction have this nature of, you know what I mean, right? So it applies here. So for you to add and subtract a matrix, it needs to have the same row and column. Yes. Now, example. If A is equal to 1 matrix 1, 2, 3, or matrix 1, 2, 3, 4. And B is equal to matrix 1, 2, 2, 3. And you ask to do what? Find matrix A plus B as I, matrix what? B, no. A minus 2B. Solution. So for this first one, this can go because it has the same words. It has the same dimension. Here we have, this is 2 over 2. It has 2 rows, the same column. 2 rows, 2 columns in A and B, right? Hence, you have A for I. A plus B is equal to 1, 3, 2, 4 plus 1, 2, 2, 3. This is equal to simply add up this first row here. 1 plus 1. 1 plus 1 for here. Here 2 plus 2. 2 plus 2. Here 3 plus 2. 3 plus 2. For here we have 4 plus 3. This is equal to, here we have what? Here we have 2. Here we have 5. Here we have 4. Here we have 7. Is that correct? Is that correct?
Yep.
Okay. Good. So for B part, for the B, which is II, which says for A times minus 2B implies matrix A. Please 1, 3, 2, 4 minus 2 matrix 1, 2, 3, 2, 3. This is equal to equals. First of all, let's rewrite this and deal with this side first. We have 1, 3, 2, 4. Hence, this thing means using what we use minus 2 to distribute inside what we have here. Hence, we have minus 2 minus 4 minus 2. This should be minus 4 minus 6. Right? So this is equal to 1 minus 2 for this. Here, 2 minus 4. Here, 3 minus 4. Here, 4 minus 6. This is equal to 1 minus 2 minus 1, 2 minus 4 minus 2, 3 minus 4 minus 1, 4 minus 6 minus 2. So this is our final answer. If you follow up to this point, thumbs up. Thumbs up. Good. Okay. So let's solve this example. So we are given our A. 1, 3, 4, 5, 3, 2. And our B equals minus 2, 1, 7, 0, minus 5, 2, or maybe 3. And our C is what? 1, 1, 3, minus 3, minus 2, minus 1, 0. And we want to evaluate I. 2A plus B. 2. Want to evaluate 2A A plus 5B minus, okay, plus 5B minus let's do it this way. I 2A minus B minus C. IV A plus 2B minus 2C. So let's solve this one after the other. From the first one, which is I. So from the first one, which is I. A implies 2 into our matrix A. 1, 3, 4. 5, 3, 2. Plus our B, which is minus 2, 0, minus 5. 1, 7, 3. So this is equal to, we open up this. This implies 2, we use 2 to multiply everything inside here. 2, 6, 8, 10, 6, 4. Plus, minus 2, 0, minus 5, 1, 7, 3. Right? Hence, here we have, what do we have here?
0.
No, here we have 2
minus
2. What do we have next?
6 plus 0.
6 plus 0. What do we have next?
8 minus 5.
Good. 8 minus 5. For here, what do we have?
10 plus 1.
Good. 10 plus 1. For here, what do we have?
6 plus 7.
6 plus 7. Good. What do we have?
4 plus 3.
4 plus 3. Correct. This is equal to 2 minus 2.
0.
6 plus 0.
6.
6.
8 minus 5.
3.
10 plus 1.
11.
6 plus 7.
13.
4 plus 3.
7.
2 plus 2.
4.
5 plus 5.
10.
Okay. So, we have solved our I. Now, let's try out our II. Let's solve. Oh, you are still eating. Okay. I will do II. Then, by the time I'm done with II, you now attempt III. Is that okay? I can't see it from here. So, this implies that for II, we say that 2A plus 5B. Hence, my 2A is what? Is 2 into matrix A. 1, 3, 4, 5, 3, 2. plus 5 into what? B is minus 2, 0, minus 5. 7, 1, 7, 3. This is minus 5 or minus 7 minus 5. So this basically means that you'll be using these two to distribute into what you have here. You use 5 to distribute into what you have here. Right? If you do that, you have 2. Here we have. Here we have. Here we have. Good. Here we have. Here we have 4. Good. Plus. Yes, we have
Negative 10.
good. Here we have 0. Good. Here we have
Negative 25.
good. Here we have
5.
good. Here we have
35.
good. Here we have
15.
Great. So this implies that all this is equal to. All this is equal to. For here, we have what? 2, negative 10. For here, we have what?
6 plus 0.
Good. Here we have what?
8 minus 25.
Good. Here we have what?
10 plus 5.
Good. Here we have what?
6 plus 2.
Good. Here we have what? Good. So, what do we do next? This is equal to, here we have what? Good. Here we have what? 6. Good. Here we have what?
Negative 17. It's supposed to be 8 minus 25.
Okay. Here we have what? Good. Here we have what?
41.
Good. Here we have what?
19.
Good. So this is our answer to our. This is the answer to our. I. Okay. This is the answer to our I. So let's attempt. I and IV. Let's do this. You must not do it individually. You can work in pairs, work in groups. You don't have to do it alone.
Has worked so much, even though it's charging, the battery is running down. What are they doing? They are doing exercise. So this is 20 what? 20. Yeah, I need to post when it's 30 hours. Doesn't know how to take a break. 0 and 9. Break. I lost track. Are you keeping track? Break. Is it now?
Okay, let's go on an 8 minutes break. When we come back, we'll continue. Is that okay? Let's come back by
12.
let's come back by 12:29.
Break now. You must have completed 2 hours.
I'm like, yeah.
So many. Flat on the floor.
That's one. So what classes do you teach right now? Besides, yeah, what classes? Besides this thing.
My back hurts. No, turning into an old man apparently.
Something else you can do too, if you need to stretch your legs, put your arms behind you, grab your this, and then you put your hands on it, pull it right down.
Oh.
So you can't stretch any further. Don't hurt yourself doing that, but
Let's
from
try
a
it out.
hypermobile person, that is one of the best ways to stretch your back.
Okay.
Okay. Okay. How does this camera work? Right. Hey James, what's poppin'? How's it going? We're 28 hours in. How y'all feeling? Oh right, you're the one on the concert.
No, that was her.
Who's this dude?
I had to go to work, that's why.
Oh, I see. Wait, are you like